So your slides should look something like this, making predictions from probability. So today we're talking about doing just that, being able to predict the long run frequency of an event. So looking forward, predictions from known probabilities. Known probabilities are those we can find using theoretical probability. Two ways we can predict. One, what is the likelihood on the next try? And two, how many times would you expect in a number of tries? So, for example, if we're talking about the coin, right? We could say, if we flipped a coin, the probability of getting heads on the next go would be 50%, right? So then if we said we're going to flip a coin 40 times, you could say, well, the probability of getting heads, if we're doing it 40 times, would probably be 20 heads because of our theoretical probability of getting half, right? Now before, well, I'll pause here in a sec. But I want to show you guys, and don't let me forget, I want to show you guys some of the results of your experiment that you guys did last week with flipping a coin, what was it, doing the spinner and rolling a die. We had you guys do those as with all the math classes and see what your results were. So we're going to look at that in just a bit, and so you can see what came out of that and what those results show. Okay, so likelihood on the next try. So let's say that Nancy has a drawer of different colored socks. She's got 4 reds, 3 yellows. I'm going to draw on this a little bit. She's got 4 reds, 3 yellows, 1 green, 2 blue, 2 purple, and 6 black. So we've got red, we've got yellow, and you can be drawing on yours if you want to during this time. Red, yellow, we've got blue, green, purple, and black. Okay, she pulls the socks out 50 times without looking and records her experiment. So if she just has all these socks in a big sock drawer, she's got 50 socks. I mean, not 50 socks. She's got 4 red socks, 3 yellow socks, 1 green, 2 blue, 2 purple, 6 black, and she pulls out a sock 50 times. Okay, so let's assuming that she pulls one out, records the result. She puts it back in. She mixes it up, pulls one out, sees what color it is, records the result, puts it back in. Mixes it up. Okay, she keeps doing that. She does that 50 times. It's a lot of times. She does that 50 times, and we're going to see what she gets from that experiment. So let's just say she does that. First of all, I want you guys to quickly, in the chat, I want you guys to type how many socks does she have total, because that's going to be key here. Just real quick, I want you to type in the chat, submit how many socks she has total, because again, that's going to be pretty key to solving this. Okay. We got a couple results. Good. A few more. I want everybody participating. Good. Good, guys. Yep. So we have 18 total socks. So that means that our total that we're working out of is going to be 18. 18 socks in the drawer. And we're going to be drawing from that amount of socks, right? Okay, so let's see what happens. So she did this 50 times, and apparently there were 9 purples there were 17 black draws. There were 7 times where she drew a blue sock. Right? There's 2 times where there's a green. Where there was a green sock. 4 times for yellow, right? And 11 for red. And I'm just color coding these so it makes it nice and clear for you guys. Okay? So that was the results of her 50 draws. So predict the question asks us, predict the probability Nancy will pull a black sock on the 51st try. So if we're trying to predict that, what do you guys think that answer would be? I mean, I know there's some of these files got a little slid over. But total, we've got 18 socks, right? And she did this experiment. It looks like there's a lot of blacks here, right? In the experiments. So what do you think? What's the probability of Nancy pulling a black sock out on the 51st try? I want you guys to go ahead and answer in the Zoom chat. Think about it. Post your answer for a sec. Or post your answer, and in just a sec, we'll look at what you guys got. Again, you have your slides up that you're looking at. Guidance. Okay, and about 5 more seconds. What do you guys think? Got a couple responses so far. Great job. You guys are doing awesome. Good. I got some 33%, 33%. Good. So let's see. I'm going to share this back with you guys. And again, if you don't want my screen to take your full screen, you remember you can press escape and then it'll put it to the side a little bit. All right. So the way we can figure this out, and I know it shows it down here, but I kind of wanted to see what you guys thought because it is pretty interesting. In her drawing, right, she does have a lot of blacks, right? 17 out of the 50 tries would be, let's see what that probability would be. 34%. Okay, so a little bit higher. But we have to think about what the probability of just getting the 51st draw is. Okay, and it's just as random as any other, just like rolling a die or flipping a coin. So the number of black socks she has is 6, right? Got 6 total black socks, and then the number of total socks is 18, right? She's still drawing one sock out of 18, and then replacing it, mixing it up, drawing one, right? So the theoretical probability of getting a black sock is 6 out of 18. Okay, and that's where we get this little flow chart here. 6 out of 18. We can simplify that to 1/3, which equals 0.3333. And as a percentage, that's 33.3 repeating percent. Okay, so a third chance of getting a black sock. So a pretty good probability, right? All right, great job, guys. I think most of you guys got that. So let's keep on going here. Make sure there's any questions here if you guys have any questions. Good job. All right. So looking at this next one here, Nancy has a drawer of different colored socks. She has, sorry. Okay, sorry, same problem. This time it says, what's the probability of getting a red sock? Okay, so we have 4 red socks total, right? And we still have just double checking, we got the same numbers here, yeah. We've got 18 socks still. So the probability of getting a red sock, if she pulls the socks without looking from the drawer after 200 times, is still going to be that same theoretical probability. So even though this time she draws 200 times out of the sock bin, you still have to think, okay, what is the probability of getting a sock on this next draw? Okay, and if she's got 4 red socks, okay, and she has 18 total, it's still going to be that 4 over 18. Okay, which then simplifies. You could simplify it to what, 2 over 9, right? 2/9. And if we're going to make a prediction, so this goes with the whole prediction part. The last one, the last problem, I'll scroll up so you can see here. The likelihood of getting that was 33.3% of getting a black sock on the 51st draw. Okay. Even though there's an experiment done, this one can be predicted. Now with this, there was no previous results, right? She drew 200 times. We have no idea what the results were. But then on the next draw, we're trying to predict what the probability or the results would be of getting the red sock during these 200 times. So look here, guys. I want you guys to go ahead on your slide. I want you guys to try and circle this. Okay. Or you can write text under this, some asterisks. Frequency of the event equals probability of the event times the number of tries. Okay, so we've got the probability of the event, which is 4 out of 18 or 2/9, times the number of tries. Okay, she's drawing 200 times. So the probability of getting a red sock out of 200 times would be about 44. So I'll show you here. Say we've got 2/9, okay, times 200. It looks like out of those 200 draws from the sock drawer, she should draw a red sock about 44 times. Okay, maybe 46, it may be 42, maybe 44, but somewhere around 44.4 or 44 tries. So that's how we get our prediction here. So just clarifying, I know that's a little confusing because it's the same problem here. But just think of it this way, okay? This one we had 50 times without looking, and then we're just trying to predict the probability, that Nancy will pull out a black sock on the 51st try. Whereas on this one, we don't have any results, right? There was no experiment done. And now we say, okay, Nancy should pull out socks 200 times. And she wasn't looking. For some reason, she was distracted, and she was drawing a picture, and she was just drawing these things, and she forgot to record them. But she did it 200 times, but didn't record it. So then we say, okay, well, maybe we could get a prediction for what it should be close to. And this is what we did. Again, frequency of the event is going to equal the probability of the event, which is 2/9, or 4 out of 18 socks, times 200 times, 200 tries. When you multiply those together, you get the approximate red draws. So if it's 200 draws, about 44 of those, we said, should be red. Okay? I'm going to pause right there, ask for questions if you guys have questions, if you're not sure on something, need something clarified. Otherwise, we're going to go ahead and have you guys try a couple of these. Okay. So any questions, you can put them in the chat. All right. Again, feel free to chat as we go further. Okay. So we have this big red sign. Do this slide on the Google Drive. Google Drive link. So what I want you guys to do now is again, just next to those PowerPoint files on the first post in Google Classroom was also 2 draw files. Okay, the first of those should have a penny, a spinner, and a die. Okay, I want you guys to go ahead and open that file up. I'll stop sharing here for a sec so you can get that file open. You guys are doing great. Give you guys about, I don't know, 45 seconds to get your draw files open. You can go and get both of them open. Okay. All right. All right, so sorry, I had a question in chat. I was trying to help out. Okay, was there anybody else that could not make a copy of those files? If so, just write in the chat. Okay, awesome. I'm seeing you got it then. So let's go ahead and look at this file here. Okay, so yours should not have this giant square on it, right? So the directions say you can use probability to make predictions about the future. First, figure out the probability of a single event. Then multiply this to the number of tries done. Use the spinner below along with your knowledge of coins and regular number cubes, aka dice, to predict the events listed below. So, if you flip a coin 200 times, how many times do you think you will get heads? How many times will you flip heads? I want you guys to go ahead and fill that in on your chart and post your answer in the chat. What do you guys think? You flip a coin 200 times, what do you predict the number of heads will be? Okay, I've got one answer, good. Who else? Couple more. Again, if you're filling it out on your Google Draw, that's exactly what you should be doing. But once you get your answer, you can post it in the chat. Okay, I've got two people both saying the same thing so far. Anybody have something different, the same? What do you guys think? 50-50, so 100, okay. Good, you can keep posting in there as we go forward. Okay, good. Nice, Gabriel. Got some different options there. Maybe some different ideas of maybe the lower possibility, higher possibilities. Good. So if a coin, like we said, is, most of you guys said 50% chance, right? It's going to either be heads or tails. So if there's a 50% chance or 1/2, that's our theoretical probability, right? And then if we flip it 200 times, we're going to say, okay, well, it's 50 chance of getting a heads, landing heads. So then you say 1/2 times 200, the number of flips, right? When you multiply those two, anytime you multiply a fraction by a number, it's going to make it smaller. And if we do that here, we say, okay, 1 times 200 would be 200 divided by 2. So cut 200 in half would be 100. Right? I'm going to change my color here. Yes, Callan, I'll get you there in just one sec. So our prediction would be about half, about 100. Chat box always likes to hide. Thanks, guys. Okay. If you're still having issues with the first Google Draw, you can use this file that I'm about to post. Just make sure to make a copy. Okay. You can just copy and paste it. Callan, you raised your hand. Yeah, question in chat. Okay, Jonathan's same issue. Yeah, that's what I was saying, guys. If you were having trouble with the Google Draw, look in the chat now. You can copy and paste that, and then make sure to click make a copy so we're not all drawn on the same paper, and you should be able to get there. Okay. Awesome, no trouble. Alrighty. Again, if you're getting that file open, that's okay. Go ahead and be doing that. And we're just going to be talking through this. So the second event says if you spin the spinner 40 times, how many reds? Okay, and I'm using this draw file. So let's say there's 1, 2, 3, 4, 5 sections, right? 5 sections, and it says, what's the probability that if you spin it 40 times, how many reds will there be? Well, how many sections do we have out of the total 5 that are red? Okay, and again, looking at our picture, we say, oh, there's only one red section out of 1, 2, 3, 4, 5 sections, right? So, and I want to use a different color here just to mix things up. So 1 out of 5 is the probability of getting a red on one spin. So 1/5, and we're going to multiply that by the total number of experiments, the total number of tries. So if the spinner's spun 40 times, we have to multiply these two numbers together. And you could either do 1/5 times 40 and just multiply like that, or multiply 40 to the top and then divide by 5. So 40 divided by 5 will give us 8. Okay, so if we spun the spinner 40 times, we should expect about 8. And I'm going to draw these little approximate symbols because this is a prediction, right? It could be more than that. We could get, out of 40 spins, we could have get 20 red spins. Or flipping a coin, we could have got 3/4 heads, like we saw in that video the other day, where you got heads, 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 heads. It should be about 50-50, but who's to say that that won't happen? It is still chance. All right, so this next one I want you guys to go ahead and try on your own. If you roll the cube, you roll a die 60 times, how many 6s approximately will you get? Okay, so it's a 6-sided die. There's the numbers 1 through 6 on a die. And if you roll it 60 times, how many 6s will you get? Go ahead, find your answer, put it in the draw, and then go ahead and chat your answer. Okay, I'm getting some responses here. Good. All right. If you're still working on it, that's okay. All right. I'm just waiting to see what you guys all get. So let's see, if you roll the number cube, the die 60 times, how many 6s will we expect? Well, how many 6s are there on a die? There's only one 6, right? There's a 1, there's a 2, there's a 3, there's 4, there's 5, there's 6. So there's only one of those choices that's a 6. So that's 1 out of 6, like I wrote here. Okay, if we roll it 60 times, we have to multiply by 60. Okay, so we're going to multiply by 60, so we would get 60 divided by 6, which is equal to 10, as you guys were saying. Okay, so if we rolled a die 60 times, there's a good likelihood it'll be somewhere around 10 rolls that we'll get 6. Okay, again, this is just a prediction. This is just us using our best guess from the probability. All right, and then this last one here, if you flip the coin 96 times, how many heads? Okay, so we know, like we said before, half, 1 out of 2 is the likelihood of getting heads. And if you flip the coin 96 times, we're going to multiply by 96. 96 cut in half is going to be, let's see, 45 plus 3. That'd be 48. So we get approximately 48 times, and I should have done a different color for that one, but that's okay. All right, so approximately 48 of those flips will be heads. All right, this one was approximately 10 times, approximately 8 times, and approximately 100 times. All right, so great job, guys. You guys were getting all those correct. You guys are doing so good. Good, Jonathan. Good, guys. Good, Preston. All right, so now what I want you guys to do is look at that next slide. Okay, it should be on the same sheet. Double checking that it is. Yep. All right. So it says Alex flipped a coin 240 times. His results are in the table. What is the probability that she flips tails on the next try? Okay, so Alex flips a coin 240 times. His results are in the table right here. Okay, what is the probability that he'll flip a tails on the next go? I want you guys to, once more, I want you guys to put your answer here and type in the chat your answer as well. Okay. And once you've done that, go ahead and do the next question as well, okay? So it talks about Curtis rolling a number cube, and it records his result. Okay, so go ahead, answer those, see what you got, and we'll check in about, let's say, 1 minute or less, okay? Right. I feel like I should have some calming music, some timed music. While you guys are doing awesome. All right. Let's see what you guys got. So here's his results, right? And it's asking us to predict. Share my screen here again. Again, if that got in your way, you can press escape to get that a little to the side for you. So our goal again is to predict how many. What's the probability of him flipping heads on the next go, right? So, and let's check. Get the same file you guys are on. What's the probability that she flips tails on the next try? So even though we have these results here, right? This goes back to our first sock example, right? So the first one, where yes, there was more tails than heads, and he flips a coin. She flips a coin 240 times. But if they flip another time, the probability is still 50-50, right, for that coin. So the probability of getting a tails would be 1/2, or 50%, or 50%. Okay, and then on this next one, Curtis rolls a die, right? In fact, he rolls it. What does it say? Oh, it doesn't say the number of times. He rolls it 6 times from our table here, right? He rolls it 6 times, and we see the. Oh, sorry. It's not true. It doesn't tell us the total number of tries, but it tells us how many he rolled each. So he's rolling this die over and over again. And at the end of his experiment, he's got 30 ones, 45 twos, 30 threes, 28 fours. Okay, he's got all these different results. Now, the probability he rolls a 4 on the next try, and this is, to kind of tie this to the real world, something you can think about, is you think about people that go to like casinos and stuff, right, and they gamble. They might say, like, imagine if one of these rolls was really high, like they got 1, 1, 1, 1, and that number was really high. Or like on this one, 2s were really high. So some people, if they're gambling, right, and they don't know the probability, they might say, oh, I'm just going to really trust number 2. Number 2's on the hot train. It's going to be a lot more number 2s. But really, it's going to be the same probability of any of these 6, right? So the probability he rolls a 4 on the next try, it's going to be still 1 out of 6, guys. Even though his experiment, I got different values, it's going to fluctuate a little bit. It's still 1/6 chance of the next try. And what is that as a percentage? That's going to be about 16.6. About 16.6%. All right, let's keep on rolling. Now I'm talking too much, maybe going too slow, but I just want to make sure that you guys really understand the differences between this, where we're just predicting the next one, and if we're trying to predict results after a certain number of flips. All right, observational probabilities are those we can find using experimental probability. Again, 2 ways we can predict. So compare this to our first one. This was theoretical probability. And this one is experimental. So 2 ways we can predict. What is the likelihood on the next try? And how many times would you expect in a number of tries? Okay, it's a little crazy to underline that. It's a little bit better. All right, so probability on the next try. So head back to the slides now. So Janae shot darts at a board 100 times and found that her probability of shooting a bullseye is 2 out of 10, about 20%, which is pretty good because a bullseye is pretty hard, right? On a darts, if you ever played darts. What is the probability that Janae makes a bullseye on her next shot? Okay, so first thing, is shooting darts a known probability like dice or coins? What do you guys think? I want you guys to go ahead and answer that in the chat. Is shooting darts a known probability like dice or coins? Meaning, like, is there a certain probability that we can always figure out for any person, just like dice or coins? What do you guys think? Quick fire chat. Put it in the chat. What do you guys think? Is shooting darts gonna have a known probability? I've got a no. Anybody else? Anybody think yes? Anybody think no? Got another nope. We got a couple more answers. Who's gonna be the next 2? Good job, Preston. Good job, Jonathan. Quick on the keys. Don't be shy now. I got a nah. I got a no. Good. All right. Exactly, guys. Even though there's a certain number of squares and things, it's subjective, right? If she's really bad at darts, she might not ever get a bullseye. Or if you have got a pro dart player and they're hitting bullseyes every time, they're gonna have a different probability than something like dice or coins, where it's calculated. All right, so we will need to use our observation of bullseyes to make this prediction. So what was Dana's probability of making a bullseye? Well, it said she found that her probability of shooting a bullseye is 2 out of 10 or 20%. So if we find out that she's got about a 20% chance of getting a bullseye, she did it 100 times. So what that means is out of 100 times of throwing darts, she got 20 bullseyes, right? Which simplifies to 2/10 or to 20%. So if she hits it about 20% each time, the likelihood, if we had to predict, it's not exact, right? But if we're predicting that her arm doesn't get tired and that she's still throwing the same, that she's got a 20% chance of hitting a bullseye on the next shot. Okay, so the question said, what's the probability that Dana makes a bullseye on her next shot? It's going to be that same 20%. Okay, it's not going to change probability. All right, moving right along. We're almost done, guys. Hang with us. So Janae, so there's another one, predicting the frequency of an event. Okay. So this one says, Dana has observed that she hits the bullseye 20% of her shots. How many times should Dana expect to hit the bullseye if she throws at the dartboard 200 times? So it's this time, guys, it kind of goes backwards, okay? So if she is throwing 200 times, and we know she hits about 20% of her shots, or bullseyes, how many times can we expect her to get bullseyes? Well, if it's 20%, right? To get the frequency of an event, we multiply the probability, 0.20, 20%, times the number of tries, 200 throws. And so that's going to give us an answer of about 40 times. About 40 times she will hit a bullseye. Again, it's not exact, but that's our frequency, that's our prediction. Okay, so this one gave us a result from an experiment about 20% of the time, and then we had to make a prediction about the next one. And this one said, if she hits about 20% of the time, and there's 200 throws, how many times will it hit? Okay, second draw, and then we're done. Okay, so I want you guys to make sure you open that other draw file. If you're having issues with that one, make a copy real quick of that, and put that in the chat as well. Okay, if you're like, Mr. E, some of this is not making sense, please, please, please answer in the chat and say, hey, I have a question that I'm gonna ask right after. Or, hey, I've got a question I need help with right now. If you've already got your part 2 draw file working okay, then go ahead and use that one, please, that's fine. If it's not working for you, I'm gonna go ahead and give you a link here if you need it. Okay. Here's a file you can copy and paste, a link you can copy and paste if you need help. Or not if you need help, if you need help with the draw file, sorry. All right, I'm gonna pull mine back up. You guys are doing great. Hopefully this is making sense. And it's not too bad. I mean, I think probability is one of those things that you can kind of reason, you can kind of think in your head and grasp with not too much trouble. It's just making sure that you're not jumping to any conclusions, that we're following the right steps. All right. So I'm going to go ahead and start for sake of time, and then if you need to, you're still working on your draw stuff, that's okay. Share screen. Okay. So Sam drove through an intersection near his home 40 times. Okay. He had to stop for a red light 30 of those times. And what is the probability that he'll stop at a red light on his next try? Sorry, making sure I got you the right question. So what's the probability that Sam will stop at a red light on his next trip? Well, let's think about that. He went through 40 times and had to stop 30 times. So from that experiment, so to speak, we could say, well, man, it seems like out of 40 times going through this intersection, you had to stop 30 times. That's about 3/4, right? 3/4 or 75% of the time. So the probability of him hitting a red light on his next go is still going to be that same percentage, right? It's still going to be that 75%. So I want you guys to make sure you draw this on your sheet here. Okay, all right. And then it says Lindsay, she was shooting a basketball, right? She shot 15 times from the free throw line in her basketball game. She has made 6 of those free throws. What is the probability she will make her next free throw attempt? Okay, so once again, she's made 6 out of the total 15 shots that she's taken. So what is the probability that she will make her next free throw attempt? I want you guys to find your answer there. Use calculator if you need to, and post it in the chat and on your slide here real quick. Yeah, hang with me, guys. Your next class doesn't start till 10:15. We will try to be done here in about 3 minutes. Okay, we're almost done. Okay, we would have been done a little bit earlier today, but with that power outage again, I'm sorry about that. I couldn't help it. My internet died. So that's why we started a little bit late. All right, so let's finish this thing up. What did you guys get? I think Preston already put his in the chat. Post yours in the chat. Show me what you got there. I don't know why it's not showing me. All right. So hopefully you guys type this in. 6 out of 15, what is that going to be? We said that's going to be 6 divided by 15. About 0.4, so that means 40%, right? So about 40% of the time she's making her free throws. So that means what's the probability she'll make her next free throw attempt? Well, about 40% chance. Okay, so a little under half probability of making that next basket, that next free throw. All right, last one, guys. I want you guys to go ahead and answer these 3 on your own. On your draw file, you will be sharing this with me, so make sure you answer these. Okay. So we use the results to predict the future. We're like fortune tellers over here. So we use those percentages to then find out how many attempts she might make in 60 attempts. All right. So I'll help you guys on this one as you're working through these. If we got 40% chance that she's going to make these free throws, okay, and she makes 60 throws, then we're going to say the probability, 0.40, times the number of throws, 60 throws, and that'll give us the approximate amount of times that she'll get it in, right? So we'd say 0.40 times 60 is equal to 24 times. Okay, so we can expect about 24 baskets if she's doing that many free throws. Okay, that would be your answer to that one. So now you guys only have 2 left. Okay, so go ahead and be answering those 2 on your draw file. Okay. As you guys are answering those last 2, today there's not going to be any quizzes. Okay. There's just going to be 2 IXL sets. Okay. That's going to be your assignment for today. So sometime today or tomorrow, I would suggest at some point today, that way it's fresh on your mind. You're going to try these 2 IXL sets. I'll post the links on Google Classroom, but it's also linked in your slides. So you can just click on them. And your goal is to get a SMART score of 80 on each of these. Okay, one deals with theoretical probability and one deals with experimental probability. And again, today's lesson is all about predicting, right? Predicting the future, kind of like a fortune teller, but we're using math to be a fortune teller. All right, so in about 1 minute, I'm going to go over these last two answers. But if you are already done with your draw files, you can share those with me to Elander@granitesd.org. And I will, we'll go over these two problems, and then you guys can go ahead and head on. Okay. All right, Abigail, just make sure you share those files with me and you do those IXLs at some point today or tomorrow. Thanks for being here. I'm not sure what you're asking there, Gabriel. You can go grab your charger if you need to. If you have your next class, you'll need it anyway. All right, good job, guys. All right. So on these last two, let's see what you guys got. So Nancy says Nancy made 5 out of 12 of her attempted shots on goal in her last soccer game. How many goals should we expect Nancy to make if she attempts 100 shots on goal? And then the other one was Megan checked her email for 30 days. She had 27 junk mail messages in that time. How many junk mail messages would she get in the next 100 days? Okay, so that would be 27 out of 100, right? And 5 out of 12. So not too bad, right? We would say 5 out of 12. That's the probability of her making a goal for shots on goal. That means if she hits it near the net. And then this one says 27 junk mail messages in 30 days. Okay, so 5 out of 12, we would get 5 out of 12. We'd get 41.6, about 41.6%. So it says, what is the probability that she's going to get, how many goals is she going to make if she attacks 100 shots? Then she'll get around that number. She'll get around 41, since it's 100 shots, 41, 42, say 42. Around 42 shots out of 100 shots. Okay. And then if she checked her email for 30 days, she had 27 junk mail messages in that day. So how many would she expect in 100 days? Well, we'll do the same thing here. We'll say 27 out of 30, and we'll multiply it by 100. Okay, and that's what I should have done here. Multiply by 100 and see what we get. So we'd say 27 out of 30 is 90%, okay, times 100. So in 100 days, we can expect her to get 90 junk emails. Okay, so that was our last two answers, about 90 junk emails and about 42 shots, or 42 goals. All right, hopefully you got something similar to that. Even if you didn't, share that with me. That way I can give you points for participating on that. And I'm trying to make sure I got my chat up. So here is my email if you need it again, Elander@granitesd.org. Any final questions? You guys are free to go. Just don't forget about the assignment. Okay, just those 2 IXLs to 80%, that's your homework, your assignment. And you got today and tomorrow to make sure you get there, okay? It is for a grade, so make sure you guys get that, okay? All right, thank you guys so much. Have a great day. Let me know if you have any questions. You can stick around and unmute your mic if you need help, if you want to talk or anything. Bye. Hey, Jonathan. Thanks, guys.